this video we will discuss Charle's law. French scientist J. Charles in 1787 studied the relationship between volume and temperature at constant pressure and presented his law that states the volume of a given mass of a gas is directly proportional to the absolute temperature if the pressure is kept constant. That is, the volume of a given mass of a gas is directly proportional to the absolute temperature if the pressure is kept constant. When pressure is kept constant, the volume of a given mass of a gas is directly proportional to absolute temperature. It means if we increase the temperature, volume will also increase. If we decrease the temperature, volume will also decrease. Now, mathematically, it is represented as volume is directly proportional to temperature. Now we will write the mathematical forms of Charle's law. Mathematically, Charle's law is represented as V is directly proportional to T. V is directly proportional to T, where V is the volume while T is the temperature. Or we can write as, it can also be written as V is equal to KT, where K is proportionality constant, or K is equal to V upon T. If temperature of the gas is increased, its volume is also increased. When temperature is changed from T1 to T2, then the volume changes from V1 to V2. The mathematical form of Charle's law will be V1 upon T1 is equal to K, V2 upon T2 is equal to K. As both quantities have same value of constant, therefore their variables are also equal to each other. So we can write as V1 upon T1 is equal to V2 upon T2. So Charle's law can also be stated as the ratio between volume and temperature is always a constant quantity. The ratio between volume and temperature is always a constant quantity. Now we will discuss experimental verification of Charle's law. This is representation of increase of volume with increase in temperature. In this figure, we have taken a certain amount of gas in an enclosed cylinder having a movable piston. If the initial volume of a gas V1 is 50 cubic centimeter and initial temperature T1 is 25 degrees centigrade. On heating the cylinder up to 100 degrees centigrade, that is T2 is final temperature is 100 degrees centigrade, the new volume V2 becomes 62.5 cubic centimeter. It means if we increase the temperature, then volume will also increase. This is the experimental verification of Charle's law. I hope this is clear to you. Now we will study graphical explanation of Charle's law. When we plot a graph between volume and temperature by taking the volume at x-axis and temperature in Kelvin along y-axis. When we plot a graph between volume and temperature, we get a straight line. Straight line between volume and temperature proves that there is a direct relationship between temperature and volume of a gas at constant pressure. That is, volume is directly proportional to temperature. Greater the temperature, greater will be the volume. I hope graphical explanation of Charle's law is clear to you. Now we will do some of the important numericals of Charle's law. Let's see what is the first numerical which is given. A perfect elastic balloon filled with helium gas has a volume of 1.35 into 10 raised to power 3 cubic decimeter at 1 atmosphere and 25 degrees centigrade. At 15 degrees centigrade, the volume of balloon becomes 1.208 into 10 raised to power 3 cubic decimeter. Show that this data satisfy Charle's law. Now first of all, we will write the data for this numerical and then we will use the formula to solve this numerical problem. To solve this numerical, we must keep something in our mind. Always convert temperature scale from 0 degree centigrade to Kelvin scale while solving the numerical problem. The formula which is used to convert degree centigrade into Kelvin is K is equal to 273 plus degree centigrade. Now to solve this numerical problem, first of all we will write the data and then we will use the formula to solve the question. Now we will write the data here. The initial volume which is given, that is V1 is equal to, we will write the value of initial volume which is given. V1 is equal to 1.25 into 10 raised to power 3. 1.25 into 10 raised to power 3 cubic decimeter. This is the value of initial volume. Initial temperature, that is T1 which is given. T1 is equal to 25 degree centigrade. 25 degree centigrade. Now we convert degree centigrade into Kelvin by adding 273. 273 we know K is equal to degree centigrade plus 273. So by the addition of 273 we convert it into Kelvin. It becomes 298 Kelvin. 298 Kelvin. Now the final volume which is given, V2 is 1.208 into 10 raised to power 3 cubic decimeter, and the final temperature T2 which is given, T2 is 15 degree centigrade. To convert into Kelvin we will add 273. By the addition of 273 it becomes 288 Kelvin. Now we use the formula V1 upon T1 is equal to V2 upon T2 and then we will substitute the values in the given formula. That is V1 upon T1 is equal to V2 upon T2. That is, the ratio between initial volume and temperature is equal to the ratio between final volume and temperature. Now we will substitute the values. We know V1 is equal to 1.25 into 10 raised to power 3. 1.25 into 10 raised to the power 3 and T1 is 298 Kelvin. 298 is equal to V2 is equal to 1.208 into 10 raised to power 3. 1.208 into 10 raised to power 3, while T2 is equal to 288. 288. By solving, here we get 4.19 is equal to 4.19. The ratio, that is V upon T, is 4.19. It is a constant value. This value shows that the volume of a gas is directly proportional to absolute temperature according to the Charle's law. I hope this numerical is clear to you. Now we will see the next numerical which is given to us. A bacterial culture isolated from sewage produces 36.4 cubic centimeter of methane gas at 27 degrees centigrade and 760 millimeter of mercury. This gas occupies 33.124 cubic centimeter at 0 degree centigrade and same pressure. Explain volume temperature relationship from this data. Once again, we will read the numerical which is given and then we will solve it. A bacterial culture isolated from sewage produces 36.4 cubic centimeter of methane gas at 27 degrees centigrade and 760 millimeter of mercury. This gas occupies 33.124 cubic centimeter at 0 degree centigrade and same pressure. Explain volume temperature relationship from this data. Now, to solve this numerical, first of all, we will convert the temperature which is given in degree centigrade into Kelvin by adding 273 in degree centigrade, and then we will write the data with the help of formula. We will solve this numerical. We will write the data to solve this numerical. Here the initial volume which is given to us is, that is V1 is 36.4 cubic centimeter, 36.4 cubic centimeter, and initial temperature which is given, that is T1 is 27 degree centigrade. 27 degree centigrade, to convert into Kelvin we will add 273. By adding 273 in 27 degree centigrade we get 300. So in this way we convert degree centigrade into Kelvin. The final volume which is given, V2 is equal to 33.124 cubic centimeter, 33.124 cubic centimeter, and the final temperature which is given is 0 degree centigrade. T2 is 0 degree centigrade. So we write here T2 is 0 degree centigrade. Convert into Kelvin by adding 273. It is equivalent to 273 Kelvin. Since in this numerical pressure is remain constant, so that's why we will apply Charle's law. According to Charle's law, the formula which is used here, according to Charle's law, V1 upon T1 is equal to V2 upon T2. Now we will substitute the values, that is 36.4 divided by 300 is equal to, the value of V2 is equal to 33.124. 33.124 divided by the value of V2 is, the value of T2 is 273. By dividing 36.4 with 300 degree centigrade we get 0.1. Similarly, by dividing 33.124 with 273 we get 0.1. It means the ratio of volume to temperature, that is V upon T, is 0.1, which is constant. It means the value of the volume of gas is directly proportional to absolute temperature according to the Charle's law. I hope this numerical is clear to you. Now we will see some more important numericals based upon Charle's law. We will see the next numerical which is given. A sample of oxygen gas has a volume of 250 cubic centimeter at minus 30 degrees centigrade. If the gas is allowed to expand up to 700 cubic centimeter at constant pressure, find out its final temperature. Once again we will read the numerical. A sample of oxygen gas has a volume of 250 cubic centimeter at minus 30 degrees centigrade. If the gas is allowed to expand up to 700 cubic centimeter at constant pressure, find out its final temperature. In this numerical, pressure is constant, that's why Charle's law is used to solve this numerical. we must remember one thing, that is always convert temperature scale from 0 degree centigrade to Kelvin while solving the problem, and we know the formula which is used to convert degree centigrade into Kelvin, that is 273 plus degree centigrade. Now we will write the data to solve this numerical. V1 which is given, V1 is equal to 250 cubic centimeter, 250 cubic centimeter, and T1, that is initial temperature, is minus 30 degree centigrade. To convert into Kelvin, we will add 273, minus 30 plus 273 is equal to 243 Kelvin, 243 Kelvin. Final volume, that is V2 which is given, V2 is equal to 700 cubic centimeter, and we are asked to calculate final temperature, that is T2. Pressure is constant in this numerical, so we use Charle's law to solve this numerical by using the equation, that is V1 upon T1, V1 upon T1 is equal to V2 upon T2. We are asked to calculate the final temperature, that is T2, so we rearrange this formula as T2 is equal to V2 into T1 divided by V1, that is V2 T1 divided by V1. Now we substitute the values. By putting the values in this equation, we will get 700 multiplied by the value of T1 is 243 divided by V1 is 250. After calculating, we get the final temperature T2, that is 680.4 Kelvin, 680.4 Kelvin. So this expansion caused due to increase in temperature. I hope this numerical is clear to you. Now we will see the next numerical which is given. Let's see what is the statement of the numerical. A sample of hydrogen gas occupies a volume of 160 cubic centimeter at 30 degrees centigrade. If its temperature is raised up to 100 degrees centigrade, calculate what will be its volume if the pressure remains constant. Once again, we will see what is the statement of the question which is given. A sample of hydrogen gas occupies a volume of 160 cubic centimeter at 30 degrees centigrade. If its temperature is raised up to 100 degrees centigrade, calculate what will be its volume if the pressure remains constant. Now to solve this numerical, we will write the data. First of all, we will write the data for this question. The data will be, now initial volume V1 which is given to us is 160 cubic centimeter, 160 cubic centimeter, and initial temperature which is given T1 is equal to 30 degrees centigrade. 30 degrees centigrade, to convert into Kelvin, we will add 273. 273 is equal to, we will get the answer 303 Kelvin, that is 303 Kelvin. Now the final temperature T2 which is given is 100 degrees Celsius, 100 degrees Celsius. To convert into Kelvin, we add 273. By adding 273, we get the answer 373 Kelvin. We are asked to calculate final volume, that is V2. Now by using the equation of Charle's law, we will solve this numerical, that is V1 upon T1 is equal to V2 upon T2. We use the equation V1 upon T1 is equal to V2 upon T2. Since we are asked to calculate V2, so we will rearrange this equation as V2 is equal to V1 T2 divided by T1. That is V1 T2 divided by T1. Now by putting the values in this equation, that is V2 is equal to the value of V1 which is given is 160 multiplied by T2 is 373 divided by T1 is equal to 303. So by calculating we get the answer, that is 196.9 cubic centimeter. 196.9 cubic centimeter. It means the volume of the gas has increased by raising the temperature. I hope this numerical is clear to you.